So another example here with collision. We have a 3 kg cart moving to the right at 3.2 meters per second, colliding with the spring that's attached to a 5 kg cart moving left at 1 meter per second. After the collision, the 3 kg cart is moving left now at 2.3 meters per second, and we want to find the velocity of the 5 kg cart after the collision. So, again, with all these kind of questions, it's better to determine whether it's elastic or inelastic first. That influences the equation that we choose. So because these carts will have a spring in between them, they will bounce apart, and this will be an elastic collision. They will not stick together, they bounce apart. Now, like I said before, no collision in reality is truly elastic, but we will treat it that way for this. Because of that, we need to use the kinetic energy conservation equation, 1/2 m1 v1 squared plus 1/2 m2 v2 squared, etc. We still need to identify one cart to be number 1 and 1 to be number 2. I'm going to pick A to be cart 1, so we have that m1 3 kgs, v1, it is moving right at 3.2 meters per second. Just like with example 2, we'll need to take that direction into account. So I'm going to assign positive to the right. If it collides with the spring attached to a 5 kg cart, that will be m2. Moving left at 1 meter per second, so v2 would be negative 1 meter per second. Now with this equation, we do not just have v prime, we have v1 prime and v2 prime because the objects are moving separately. So v1 prime would be the 3 kg cart moving left at 2.3 meters per second, which would be negative since it is moving left. And v2 prime, the 5 kg cart after the collision, is what we don't know. Going to the equation, this one is somewhat longer, somewhat more complicated, but nothing major. 1/2 m1 v1 squared plus 1/2 m2 v2 squared equals 1/2 m1 v1 prime squared. And I know it kind of looks like an exponent of 12 there, but it is not. It's a prime and squared, plus 1/2 m2 v2 prime squared. Substituting in, m1 3 kgs, v1 3.2 meters per second, m2 is 5 kgs, v2 negative 1 meters per second, m1 again 3.0, v1 prime negative 2.3 meters per second, that will be squared, plus 1/2 m2 is 5 kgs, and v2 prime squared, because that's what we're trying to solve for. We can one-stop shop each term, so 1/2 times 3 times 3.2 squared should be 15.36. 1/2 times 5 times negative 1 squared would be plus 2.5. One half times 3 times negative 3, times negative 2.3 squared would be 7.935. And in that last term, we can multiply the 1/2 times 5 and get 2.5 v2 prime squared. Simplifying on the left, 15.36 plus 2.5 is 17.86, which will equal 7.935 plus 2.5 v2 prime squared subtract 7.935 from both sides, we'll get 9.925 equals 2.5 v2 prime squared. Divide both sides by 2.5, we get 3.97 equals v2 prime squared. And we need to take the square root of both sides to cancel off that exponent. And we get that v2 prime going to 2 sig figs would be 2.0 meters per second. And if we think about what's happening with this cart, the 5 kg cart is bouncing off of the 3 kg cart. So at the end of this, after the collision, it will be moving to the right.